Okay, I wanted to summarize this article basically because it's using some examples from the real world about AI being used in disaster management and there being some trust issues, transparency issues, and so on. So I'll be very brief. Cultivating Trust in AI for Disaster Management is the title of this article from EOS, which is the AGU newspaper kind of thing. Artificial intelligence applied in disaster management must be reliable, of course, accurate, and above all, transparent. Why is that so special for AI as opposed to dynamic models or statistical models that we have been using? Because here you are directly giving instructions to people or instructions to decision makers to take action on the street during disaster management. And AI generally is like a black box. You throw data into it and maybe combined with model output, and it spits out something, and it's not always possible to go step by step and see how the AI came up with the result or the decisions that it is proposing and so on. So, but what does transparency in AI mean? Why do we need it, and how is it achieved? The article has many points and a lot of text, so I'm going to just take some brief points from it. This is an example of floodwaters inundating a town along the Ahr river in Germany, AHR, I don't know how it's pronounced, Ahr. Artificial intelligence used skillfully and transparently could aid disaster management efforts to mitigate the impact of such events. Okay, so here the users could be people who are doing the disaster preparation, mitigation, long-term action to get ready and recovery and so on, or it could be people who are actually affected by the disaster and getting down some orders to follow, which is based on AI. So the transparency and reliability and trust issues may come for all of those. When a wildfire spreads, an earthquake strikes, or a storm makes landfall, the public depends on timely, precise, and accurate information from authoritative sources so it can effectively respond and recover. This is not any different for dynamical forecasts or statistical forecasts compared to AI. But people also expect vital infrastructure and services such as telecommunications, evacuation routes, and first response measures, to name a few, to be in place to reduce the impacts when disaster hits. So here you want to worry about whether AI can improve these steps, or give you better accuracy in predictions. We have already looked at other AI reports, papers saying Google claims it can do faster and more accurate forecasts using just AI or mixing dynamic models with AI and so on. I've talked also about how we use AI to downscale dynamic forecasts. Dynamical forecasts are given at, let's say, few kilometer scale or tens of kilometer scale. Then using data and past forecasts, we can downscale them to decision scales on floods or irrigation, health, and so on, using AI, right? In communities and countries around the world, humans aided by traditional technologies such as physical-based flood models and numerical-based weather forecasts meet these disaster management expectations as best as they can. Increasingly, studies show that artificial intelligence can build on and supplement these traditional technologies, which already we've talked about. However, AI-based disaster management tools, like their non-AI counterparts, can fail. Furthermore, the complexity of some AI algorithms make it difficult to pinpoint the causes of failure. When the forecasts fail from a dynamic model, typically climate forecasters go back and bang their head and see what they missed and try to learn from them. Mitigation and adaptation and disaster disaster mitigation includes actions taken well in advance of a disaster, such as purchasing insurance to minimize potential financial burdens and constructing barriers to hold back future flooding and so on. Preparedness, of course, is actions taken as a disaster becomes imminent, including forecasting, monitoring its progress, preparing shelters, stockpiling disaster supplies, and so on. And the response phase covers actions taken during a disaster, and then there is the recovery phase where it could be sometimes horrible because buildings collapse. You may be looking for people, or flood leaves a lot of mess behind. You may be cleaning up. People's houses may be having a lot of mold, and health issues may emerge, and so on. Transparency with respect to data, training, evaluation, and limitations for AI for disaster management is therefore critical to ensure the safety and robustness of these tools. Transparency helps people trust the system, and then it becomes easier to get them to follow early warnings and so on. AI and the 4 phases of disaster management. We already mentioned disaster mitigation, preparedness, response and recovery. So we will look at a figure. So here you can see the figure from this paper. So AI can contribute to mitigation. So those are, if you know a region or a place is prone to floods and or is having more frequent floods, then you begin to have mitigative measures like how to get the water out more quickly, drainage systems, permeable pavers, rain gardens, and etc. etc. Preparedness, of course, and response and recovery. So then recovery can again teach you about what else is needed for mitigation, because you want the recovery to functionality to be as quickly as possible. There are many details about the welfare networks, social networks help for people to recover based on their socioeconomic status and so on and so forth. So recovery phase refers to actions after most of the damage has occurred, including impact assessment, debris removal, reconstruction and so on. And AI technologies, including machine learning algorithms trained to recognize patterns in dataset, are showing great promise for beneficial use in all 4 phases, even outperforming some traditional tools in terms of accuracy and efficiency. This is the critical part, that now we are relying more and more on AI, and obviously we are on a bandwagon now. Everybody is saying AI does better, and often, as we talked about in the previous podcast on sustainably using AI, we are not necessarily doing cost-benefit analysis of the additional accuracy or efficiency added by AI compared to the amount of energy it uses or water and so on and so forth. Okay, so AI is being used to identify vulnerabilities, and there are specific tools like OneConcern, which is combining AI with virtual representation or digital twins. Digital twins are becoming more and more common, where you have a complete computer model of, let's say, a city, where you can sit and navigate the actual city on the computer with a digital twin. This is like what we used to have before called CAD/CAM, computer aided design, and computer aided machines, I guess, models, whatever it was, I forgot, where we used to build things on the computer first, make sure that it works, and then we used to fabricate them and so on and so forth. There are other projects like Destiny project is building digital twins of the entire Earth system and so on. Using different approaches, Gazze et al. Applied AI to understand traffic during hurricanes, which can help urban planners strategically position sensors to catch traffic flow and enhance situational awareness and so on. So this is how it works. Using a combination of satellite imagery and data on roadways, AI can be trained to optimize the placement of traffic sensors to best capture traffic data, evacuation routes to be optimized, buildings and critical infrastructure, flood risk map is needed, of course, and number of lanes and speed data, etc. are used to safely get everybody out of harm's way as quickly as possible, or as early as possible, because evacuations obviously need to be well ahead of time. Otherwise everybody is going to get stuck on the road instead of being at home with boarded windows or so. So timing matters a lot. AI can support preparedness by contributing to forecasts. So there is AltaML, European Center for Medium, so ECMWF is adding AI to its publicly available forecasts. Google DeepMind, that I've talked about elsewhere, NVIDIA is doing its own thing, Huawei is doing, and also benefits of algorithms now include reduced computational costs, high accuracy with respect to global metrics, and certain extreme weather events. So we are still exploring this space, and everybody is trying to do it, especially big companies like Google and NVIDIA, which have massive resources, same as Huawei and so on. So obviously there is a lot of demand for these. Insurance companies would pay a lot of money for these, and so on and so forth. So there are examples. AI's ability to detect and monitor hazards can also enhance preparedness. So there are things like Alert California and Cal Fire, and it had some examples where it detected fires before people actually started saying there is a fire. Google has also mentioned this, saying that their search term algorithm detects flu before CDC does, the Center for Disease Control in the US does, because people are searching for flu symptoms when they get flu, and if the number of searches reach a certain threshold, then you can say this region has exploding flu. So there are other examples that I won't go into. So during the response phase, AI can provide situational awareness and decision support for disaster management effort, and there are other examples here as well. Why am I jumping over these? Because these are not terribly new as to what AI can do. The main issue is then about the importance of transparency. So this is the paper this paper keeps referring to in Natural Hazards that came out in 2020, I think. Yeah, 2020. And it is a meta study which looked at a large number of published papers on how AI was used in disaster mitigation, preparedness, response, and recovery. So before disaster and during and after disaster. So examples: develop preventive laws and regulations, implement advanced codes and standards, establish zoning requirements, buy insurance, construct barriers, and so on. And preparedness, of course, prepare shelters and backup facilities, search and rescue and identify affected people during response, and during recovery you have community development, restore livelihoods, and so on. Where does the transparency issue come from? The main thing is that AI tools are basically black boxes. You throw everything in, as I said, they do something and they give you an answer, and you cannot always follow step by step exactly what it did, because they do a lot of non-linear things and multilinear, non-linear regression. I won't go into the methodologies here, but despite many positive examples, applying AI in disaster management also presents substantial challenges. One is understanding how models arrive at their results, and thus whether they are reliable. This is for people who are using them for making decisions. Humans must be able to evaluate the quality of AI-generated information before using it to make important decisions. Often, however, end users are not provided information about how AI model is trained and evaluated. So, Google did some earthquakes in 2023 for the Turkish-Syrian border, which was a disaster, and apparently Google missed a lot of things. Maybe it was lack of data, but either way, Google didn't share the process completely for people to understand what went wrong, whereas there are other examples of the USGS tool which is more transparent, but the more you apply the tools, the more will be examples of failures, and then transparency is about saying why things failed. Decision makers may use the AI-based tools repeatedly and learn how it does, but when it fails, they also need to understand in what situation it may fail. So, a seeming lack of transparency from Google about how the system operates, how well it works, and how users responded to surveys about the system's functionality following the event has raised concerns about the system's reliability and about if and where it failed. This can be a problem, of course. Sometimes AI algorithms might not perform as expected because of deficiencies in the data used for training or as operational input. AI, ML, deep learning, etc. obviously require a lot of data. More the data, the better they do. If you don't have data, they may do something to manage, but then reliability and skill efficacy, whatever we call it, may suffer from that, right? So, another avenue by which AI is being applied in disaster management is in chatbots. By generating text from the United Nations Educational, Scientific and Cultural Organization, or UNESCO, AI can provide guidance and decision support during disasters. However, AI chatbots can raise additional challenges if they hallucinate, that is, if they generate convincing but unreliable answers that could be misleading or even dangerous. Okay, so complexity of AI then makes all these issues important. So transparency must be also meaningful. In other words, the information provided to stakeholders should be complete and understandable to enable informed decision making. AI developers should implement fail-safes such as involving human oversight so that the entire process is not automated and you don't know where to intervene if things start to go wrong. So decision making has to be supported that way, but AI literacy of human end users is also necessary, and combating cognitive biases such as users' tendencies to rely too heavily on algorithms. Together, these approaches can ensure the safety and robustness of AI tools for disaster management, enhance trust in them, enable the replication of methods, and contribute to more efficient transfer of knowledge and capacity sharing among current and potential users of the technology. So reproducibility is very important, because if you are doing something and only you can do it and nobody else can do it, then it can be tricky, right? It's not like a dynamic model, which is just a model that's running and then it's producing some output. AI has to be trained locally based on local data, and then when you move it elsewhere, again, it has to be trained with that data and so on. So reproducibility is very critical. Then what are the steps to success? Two deliberate steps that academic researchers, companies, and others developing AI-based tools for operational disaster management can take to foster transparency include sharing comprehensive documentation and undergoing regular independent audits. Seem obvious, yet they have to be codified. Documentation such as open access metadata, data sheets, and other publications should disclose the origins and characteristics of AI training data according to the FAIR, that is, findable, accessible, interoperable, and reusable principles, and should detail how these data have been processed. There are other details like consideration of data quality, and approaches should be safeguarded again, for sensitive information, build public confidence in the resulting AI application. So if you are doing something on health and you have fed all the people's data into it so that it can do vulnerability and predict who is most likely to get affected when flu season comes or so, then you have to make sure that sensitive information is safeguarded, privacy concerns are preserved, and so on. During training and evaluation of an AI model, it's important to follow best practices to ensure the reproducibility and validity of the model. Modeling methods, decisions, limitations, and ethical considerations should be disclosed and documented in a short file called a model card. That's a very specific recommendation, which can be disseminated in publicly available materials on platforms such as GitHub and GitLab, or on open access journals. There are other advices like white box, which is an algorithm such as causal tree that are inherently interpretable, or if a higher level of complexity is necessary, combining black box models such as deep neural networks with explainability methods. But I am not sure if such specific recommendations can be made, because people who develop these tools will use what they feel is the best, and then they test for reproducibility and validity and so on. Okay, but the equity and justice issues are critical, because if you are managing a disaster at a city level and there are various socioeconomic strata living in different places, you need to make sure that information is not biased in any way towards rich people or disadvantaging the poor people or the women or the children or the elderly and so on. This is not all guaranteed when you feed everything into AI. So finally, when AI model is operationally deployed, it is important to convey its uncertainties and thresholds clearly to users. For instance, what level of uncertainty in the model output is tolerable, and what threshold must be crossed for an early warning of an earthquake or flash flood to be triggered, so that people know when it says a flash flood is coming or an earthquake is coming, they know what the level of certainty is, what the probability is. Some sort of a training is needed to understand the forecast, because it will not be yes or no, it will be maybe 30% chance, 60% chance, and so on. So you have to understand what they are. Also, what technical requirements such as internet connectivity must be met for such a warning to be received. So if you are on a list which is supposed to send you a early warning, then can you get it if the power is out? Do you need a network? Do you need internet? Do you need a computer, or can it be done on a phone, and so on? So finally, it's imperative for developers to conduct regular audits and public reporting of the AI systems they are designing and implementing, of course, independent evaluations, etc. Public reporting of findings promotes transparency and encourages continuous improvement. So co-development, sustained feedbacks to make the systems better and more easily understandable and usable and actionable for the people as well. In addition to sharing comprehensive documentation and undergoing regular auditing, we emphasize the importance of integrating stakeholders and end users in the development of AI-based systems or co-developing the systems. Such multi-party and interdisciplinary collaboration is vital for disaster management, in which various groups must work harmoniously in critical conditions. So though partnerships among AI researchers, natural hazard experts, disaster management experts, policymakers, and members of affected communities, through partnerships among all these, AI development becomes more inclusive and responsive to diverse needs and more transparent to all levels of stakeholders. Okay, so there are many examples here of international strategy for disaster reduction, United Nations Office of Disaster Risk Reduction, focus group on AI for national disaster management, even global initiative on resilience to natural hazards through AI solutions, and so on and so forth. All these give you protocols, frameworks, data sharing, and essentially foster transparency and common standards, which are very useful. So these steps toward collaborations and transparency, especially in all the documentations, implementation, and public presentation of AI systems, are critical to the success of AI for helping at-risk communities worldwide through disaster mitigation, preparedness, response, and recovery. And obviously, once people are involved, you can do crowdsourcing of data. For example, if you are predicting floods, as we are trying in the city of Mumbai, you can tell people to tweet what they are seeing in their neighborhood. Heavy rain, actual flooding, what level of water is standing there, what the traffic is doing, and so on and so forth, so that as we keep issuing forecasts for 15 minutes, few hours, or even 24 hours, we know how our forecasts are doing, and if we are understating the chances or overstating the chances, and help the actual decision makers who have to flip on drainage pump or something. And so crowdsourced data helps a lot in these sorts of way. Okay, so let's leave this here. It's just that there are additional points made here about transparency, reproducibility, validity, trust, and so on, that we have to keep in mind when AI is used for disaster management, which is very different than improving models, because here lives are at stake. Decision makers need quick ability, input, predictive information to make decisions on disaster preparedness, recovery, and rescue operations, and of course feed them back into the mitigation process, which is a longer term strategy to reduce the impacts as disasters continue to happen. Risk is not zero, but managing risk is always critical with all the tools we can get. Okay, see you in the next topic.